Now for the remaining problems. So go ahead and put key on this thing. The second one, these are across from each other. They go across the vertex. That's an example of vertical angles. The way vertical angles work, remember that they look the same. They actually are the same. So all you got to do is set up the equation b equals 43. On that one, there's really no work to do because it already gave you the variable. You're finished. Number 4 over here, this little square in the corner means that they are complementary. So this is complementary angles. So that would be the relationship. The way that those work out is you can add them together and they're supposed to equal 90 degrees when you do that. That was because they're complementary, so that would be your reasoning why. After that, if you need to move this 63 across the equal sign, you're subtracting it from both sides. That would be the subtraction property. I'm gonna put SUBT for subtraction, PROP for property. You work that out. On the left side you get B, and on the right side this is 27. So you found your variable, 27. Number 5, these two make a linear pair just like number 1 did. So this will be linear pair. To do the work on this one, you would add these up and make them equal to 180 degrees because that's what linear pair does. So it'd be B plus 35 equals 180. Then you would want to move this 35 out of the way. You'd do that by subtracting it. That's the subtraction property again. Putting it right there, subtraction property. So you get B equals, that'd be 145. So that would be the angle right there. Number 6, you've got this little square in the corner means that these two angles add up to 90 degrees. This line that goes through that same vertex is splitting it up, but it's still, these two are complementary. Doesn't matter about these angles out here, don't do anything at all. It's just these two. So the rest of the drawing is just making it look more complicated than it really is. So just worry about these two angles and go, these two are supposed to be complementary. That means they add up to 90 degrees. I'm gonna put complementary right here. Angles, I'm gonna put the symbol because I'm running out of room. So that little angle symbol and then S for plural. You need to move this 29 across. Again, we subtracted to do that, so that's a subtraction property right there. B is 29 would go away, be 61. There's your answer. Number 7, we're kind of like what happened on number 3. These do not have a special name to them. They just all add up to 360 degrees because it goes all the way around. So we're still going to say that there's no relationship. There's no name for the relationship. So I'm going to put that right there. And then we're going to add these 3 together, B and 94 and 243, and make them equal 360 when we add them up. First step, we'd be combining those two. That's combining like terms, CLT for combining like terms. We get B plus, and then 94 plus 243. I'm gonna need my calculator for that. 94 plus 243. I get 337 when I combine those like terms. After that, we're moving this across the equal sign. We're subtracting, so that's subtraction property again. And when I subtracted it with my calculator, I got 23. So there's the answer for B right there. Number 8, even though you see this triangle here, the triangle part's not really doing anything. The only thing that really matters is that those two angles make a straight line. So that's linear pair. And for linear pair, you add them up and equal 180. So B plus 49 equals 180. Subtract both sides. That's subtraction property. 180 minus 49 gave me 131. Ooh, that looks sloppy, sorry. It says, it's gonna say subtraction property. So subtraction, S-U-B-T, and then property, P-R-O-P. Wow, 6 in the morning. I got a lot of people texting. Bunch of early birds. Okay, number 9 over here. This little ray that's shooting out of that vertex is doing absolutely nothing for us. If we didn't have that, it wouldn't change the problem. So all you got to do is realize that those two are linear pair. Linear pair. You know what the relationship is. And the linear pairs add up to 180. So the 3x plus 18 and the 93 equal 180 degrees. After that, we would be combining those two numbers. So that's combining like terms. So CLT. 18 and 93. 111. After that, we need to move this 111 over. So you're going to subtract to do that. That's subtraction property. That gives us 69. So 3x gives us 69 because of subtraction property. Last step, we need to divide to get the 3 all by itself. So if subtracting is subtraction property, when we divide, it's division property. Div property. So division property. And we finally get x equals 23 as our final answer for that problem. Number 10, this line that cuts across the vertex is doing absolutely nothing again. If I cover that up, it does not change that those angles that I care about are vertical angles. So I'm going to write vertical angles for my relationship of what's going on with these two angles I care about. And then you have 2 plus 3x equals 62 because of the vertical angles and what they do. We need to move this 2 across the equal sign. It's a positive, so we're subtracting. Since we subtracted on both sides, we're back to subtraction property. Again, sorry about my handwriting. That says subtraction property. Then you get 3x equals 60, just 60. Now we need to get rid of this 3. It's multiplied. We do the inverse. We divide. So because we divided, that's the division property. And then we get x equals 20. That's our final answer for this one. On the back side, these are all segment addition postulate. So I don't have to write down what the property is, what the postulate is. I already know, segment addition. This problem, you have all the way across is 13. The part on the left is the part that we already know, and we want to know the part on the right. So to write that out, I'm going to put a variable right here. I'm going to use x. 1 and x together makes 13 because of the segment addition postulate. I'm going to subtract 1 and move it across. That's the subtraction property. So I'm going to write that right here, remind myself. And then final answer, we would go ST equals 12, or x equals 12. So ST equals 12. That would be the best answer right there. Okay, number 13 over here. I'd skipped that one earlier. Again, all the way across is 32. This part is the one I don't know. 20 is over here on the right side. I'm going to use a variable again. So I'm going to put x and 20 together are supposed to make 32. Subtract 20 to get that out of the way on the left side. And that'd be 12. So the only thing I had to do here was knowing segment addition postulate, set up the equation, and then subtracting, which is subtraction property, to actually solve. Number 14, segment addition. I have the left side, I have the whole thing. I need to know what's the right side. These two add up to make the whole thing. So I'm going to put 14 and x together on one side and 30 on the other. Need to move this 14 out of the way. So I'm subtracting it to move it to the right side. And that's giving me 16. And the only thing I had to do here was subtraction property. Number 16. Now we have this little piece is 2 from G to H, and we don't know this piece from H to I, but we know that from G to I together is supposed to be 7. So I'm going to pretend 12 is not even there. I'm just looking at those two segments right now. And in that spot, I'm going to go, well, those are supposed to add up to make 7. So X and 2 should make 7. I'm going to subtract using the subtraction property. And now I know that this part is 5. So I don't need X anymore. I can put that as 5. Then the question asks for HJ. Be careful. Make sure you're reading the directions and the question and make sure you're answering it. So HJ would be this piece from here to from H to I, which is 5, and it would be this piece from I to J, which is 12. So that's using the segment addition postulate two different ways for this problem. So your final answer, the one that would get you credit if it was a test, would be once you add those together, that'd be your answer. So right here I use subtraction property, right there, subtraction property. And then right here, what I did on this step was combining like terms. Number 17, this is kind of like what was happening on 16. We're gonna have to do it in segments. So first it says find EC. We know that at the end we're gonna find out what's all of this together. But to do that, we need to know what's ED. The way we're gonna have to do it, let's start with this segment over here, these two on the right, because if we have one missing segment, then we can do the problem. So right now I'm gonna call this X for now. These two segments add up to 30. So the X and the 16 is supposed to give me 30. Subtract, X is 14, yay. Okay, I know this is 14 from C to B. Then the next part is I know that the entire thing from E to B all the way across is 49. And I already know these two parts. This is the only one I'm looking for. I'm gonna use a different variable because I already used X. So I'm gonna call this one Y. You can use whatever variable you like because it's not your final answer anyway. So if you already know that these three sections are supposed to add up to the 49 all the way across, that's the equation you're gonna write. The Y and the 16 and the 14 all add up and make 49 going all the way across. First, we're gonna combine like terms right here. That's 30. And all I did for that was combine like terms, CLT. Over here, I almost forgot to put that the only thing that I did here was subtraction property. Now that I've combined these like terms, I need to move that 30 across the equal sign. Right now it's a plus, but that's not what I'm doing. I'm going to be subtracting 30 and getting Y is 19. And the way I did that was subtraction property. And you know it's subtraction property because that's what you did. Not what was in the problem, but what you did was you subtracted. So subtraction property. Number 18. Go on the right side, this smaller piece is 31 from J to L. So let's go like that. We're going to start here and find this segment. So we know that those two are supposed to add up to 31 because of segment addition postulate. So X plus 12 together should make 31. Then you're subtracting 12 from both sides. That's subtraction property. And you get X equals, what is that? It's too early in the morning. Sorry. 31 minus 12. Some of you already know what it is. I know. 19. Okay, now we know that this little section from K to L is worth 19. Once again, these three segments all together should go all the way from I to L, which is the 49 right here. I'm not going to use X because we already did that. I'm going to go with Y and go Y and 12 and 19 all should equal 49 all the way across. Just like the last problem, combine like terms right here. 12 and 19, 31. Oof, why did I put an equal sign? Sorry, plus. And then 49 over here. Then we got to move this 31 across. To do that, we're subtracting, so that's subtraction property. Y equals 18. So the first piece was combining like terms. The second piece was subtraction property. Ta-da! And then the very last problem. It's all in words, all in symbols. Let's give ourselves a little diagram to work with. It says find AC if AB is 13 and BC is 9. So A, B, C are the letters we're dealing with. AB is 13, BC is 9, and we're looking for all the way across. Pretty simple. These two little pieces add up to the whole thing across. So we're just gonna go AC is 13 plus 9. So AC would be 22. And all we had to do on this step was right here, we combined like terms.